Ever feel like you're just stuck tweaking settings, like in the dark, hoping for the best, but not really sure what you're doing?
Yeah, yeah.
Today, we're diving into a paper that tackles that exact problem. How to make the best decision when you've only got a black box to work with.
Wow, I like this already. And before you picture an actual black box, think of it this way. It's any system where, you can put stuff in, you get stuff out,
Right.
but you have no idea what happens in between.
It's a mystery.
Exactly.
Like my coffee machine, I swear, total black box. Beans in, coffee out, but finding that perfect brew setting, total mystery.
It is, it is.
This paper gives us a framework to maybe crack the code. And not just for coffee, but for any black box situation.
Yeah, and it's a framework we kind of use intuitively all the time, whether we realize it or not.
Okay.
It's this balance between exploring new options and then exploiting the ones that seem to be working.
So like with my coffee, should I just keep experimenting with every ratio of water to coffee beans under the sun?
Yeah,
Or do I just say, this is good enough and stick with it?
that is a great question. And this paper, Optimum Statistical Collaboration Towards General and Efficient Black Box Optimization,
Catchy title.
it gives us a way to think about that balance mathematically.
Okay, so no more just relying on gut feeling.
A little bit more than that.
Sign me up. So let's unpack this whole optimum statistical collaboration thing.
All right, so it all boils down to two main components. The first is what they call the resolution descriptor, or OE for short.
Okay.
And think of it like this. You're at a carnival, you're trying to win the biggest prize, right?
Okay, yeah.
OE is how big that prize could be, like the potential for how much better things could get.
Okay. So OE is all about the potential payoff, right? What about the second component?
All right, so the second is what they call the uncertainty quantifier, or S. If we stick with our carnival example,
Okay, yeah.
SE is how sure you are that you've found the easiest game to win that prize.
Oh, okay, I see. So OE is like how big is the potential reward, and SE is like how confident am I that I have the best strategy right now?
Exactly.
Gotcha. How does this optimum statistical collaboration tie those two things together?
I'm glad you asked.
Yeah.
So imagine this. Let's say you're wandering through a forest.
Okay.
The path keeps branching.
Okay.
Algorithm 1, or OSC, as
Yeah.
it's called in the paper, is basically saying keep exploring new branches until the potential for a better view, that's your OE,
Right.
is smaller than your uncertainty about whether you're on the best path already. That's your SE.
So it's like if I think there's a really good chance that a better view is just around the next bend, I'll keep exploring.
Yeah.
But if I'm pretty sure that I'm already close enough to the best spot, maybe I'll just stop exploring and just enjoy the view.
Exactly, exactly. It's all about knowing when to keep experimenting
Yeah.
and when to just be like, you know what, this is good enough based on what we know.
And this paper takes it even a step further, right?
It does.
They created a whole algorithm based on this.
Yes. They call it the Variance Adaptive High Confidence Tree, or VHACT for short.
VHCT sounds very,
Catchy, right?
yeah, like something out of a sci-fi movie.
A little bit, but it's actually pretty intuitive when you really break it down.
Okay.
VHCT takes these principles of OSC and it puts them into action. And we talked about uncertainty.
Yeah.
Well, VHCT gets even smarter by considering the noise in the feedback that it's getting.
Okay, so it's not just about whether something works, but how consistently it works.
You got it. Like, think about it like trying to perfect a cookie recipe.
Okay.
So you're trying to recreate your grandma's famous chocolate chip cookies.
Who wouldn't want to do that?
Right.
Yeah.
So VHCT would not only consider how delicious each batch is,
Right.
but also whether the results are consistently amazing
Yeah.
or if they're all over the place.
Okay.
So is it my oven or am I just bad at measuring flour?
That's brilliant. So VHCT is basically saying, hey, if the tweaks I'm making can making these cookies amazing, maybe I don't need to try a million other variations.
Exactly. It's like having this built-in skeptic, that's saying, hold on a second, let's not get too ahead of ourselves. We need more data before we can really say we've nailed it.
I love that. It's like VHCT is like protecting us from those premature eureka moments, that turn out to be totally wrong.
Exactly.
Okay.
And that's where this variance adaptive part of VHCT really comes in.
Okay.
You see, a lot of the traditional methods, they use a fixed, kind of a worst-case estimate of uncertainty.
Okay.
But VHCT is dynamic.
Mm-hmm.
So it adjusts its confidence level based on how consistent the feedback is.
So it's like if my results are all over the place, it's saying, okay, I need to be a little more cautious here. I need to explore more.
Right.
But if it's consistently positive, it can be like, all right, we're on to something. Let's zero in on this.
Yes, yes, exactly. It's about making the exploration process smarter, more efficient. And what's really cool is that VHCT, it doesn't rely on these overly simplistic assumptions about smoothness that a lot of the previous research used.
Okay, so explain smoothness to me.
Yeah.
You mean like assuming that the path to the best solution is always just like a smooth, predictable uphill climb.
That's a great way to put it.
Yeah.
Yeah, because in reality, it often feels more like a bumpy road with like detours and stuff,
Yeah, exactly. Exactly.
And this is where VHCT shines. So previous research often relied on this idea of exponential local smoothness,
Okay.
which basically assumes that as you get closer and closer to the optimal solution, things are going to improve exponentially. But VHCT, it takes a more nuanced approach.
So instead of assuming like this perfectly paved road to the finish line, it's ready for anything.
Exactly. It's built for those situations where the optimal solution might actually be hidden in those twists and turns.
Gotcha. So they actually put this to the test, right?
Yeah,
Because it's one thing to have a fancy algorithm, but it's another thing for it to actually prove itself in the real world.
oh, absolutely. They tested VHCT on all sorts of problems. We're talking classic optimization challenges, real-world scenarios, like tuning machine learning models.
So they didn't go easy on it. They
Not-
really put it through its paces.
And what they found was that VHCT consistently outperformed existing methods, especially when dealing with these more complex, unpredictable situations. It's like they built this all-terrain vehicle, right, that can handle any terrain, while other algorithms are still stuck on the paved roads.
That's a great analogy. And that's what's so exciting about this. It's not just about finding like a slightly better way to tweak settings. It's about fundamentally changing how we approach solving problems when we're dealing with uncertainty.
Exactly. And while, VHCT is a really cool achievement in itself,
Yeah.
what's really significant is this broader framework that it represents, this idea of optimum statistical collaboration. It has the potential to completely change how we make decisions in a lot of fields, really.
So it's not just about algorithms, it's a whole new way of thinking.
Exactly.
Yeah.
It's about finding that sweet spot between exploring the unknown and exploiting what we already know. And that's a skill that's super valuable in pretty much every part of life, wouldn't you say?
Totally. Totally. From choosing your career to, I don't know, like finding the right apartment, life is full of black box problems.
Absolutely.
And this research gives us this powerful new tool to deal with those uncertainties. Speaking of uncertainties, though, I'm curious, did they leave any stones unturned? Like, what are the unanswered questions in this field?
I love that you asked that because, what I like about really good research is that it doesn't pretend to have all the answers. And that paper is a great example of that.
Okay, so what are some of the things they still don't know? Or the questions this raises? What are those next big frontiers in this world of black box optimization?
But one of the big things they talk about is the need for algorithms that are even more adaptable. And especially when it comes to that smoothness factor we were talking about.
Right, because in the real world, we don't always know how smooth or bumpy the road is going to be, do we?
Exactly. Imagine an algorithm that could just automatically adjust its exploration strategy based on the problem without us needing to tell it about the smoothness beforehand.
Okay, so it's like having an all-terrain vehicle
Yes.
that can seamlessly switch from like a smooth highway to a rocky mountain path without,
Without missing a beat.
without me having to manually switch gears or anything.
Exactly.
That would be incredible.
It would be amazing. It's about making these algorithms as adaptable and as resilient as we are when we deal with uncertainty.
So what are some of the real-world applications of this? We've talked about, coffee machines and cookies.
The important stuff.
Exactly, the essentials. But where else could this optimum statistical collaboration idea make a real impact?
Oh, the possibilities are endless.
Give us the good stuff. Where could this technology really shake things up?
Well, think about personalized medicine.
Okay.
You've got doctors, they're trying to find the best treatment for each patient, right?
Right.
But everybody's body's a little different.
Totally.
It's like its own black box.
What works for one person might not work for someone else, and you definitely don't want to be like experimenting on someone's health.
Right. Trying to find that perfect treatment through trial and error when the stakes are so high.
Exactly.
This is where these kinds of algorithms like VHCT could really change the game. They could help doctors navigate those decisions so much more efficiently.
Yeah. It's like having this super-powered medical assistant
Right.
that can analyze all of your data as an individual, look at
Hmm.
all the options, and then be like, okay, based on everything, this is the best path forward.
Exactly. But it doesn't stop there.
Yeah.
What about self-driving cars?
Oh, yeah, good point.
They are constantly having to make these split-second decisions in crazy environments.
Avoiding obstacles, navigating traffic, reacting to things you totally don't expect.
Yeah, it's like a real-time black box optimization problem on wheels.
Totally, totally.
And the better those algorithms can get at, finding that balance, that exploitation balance, the safer and more efficient those cars will be.
So we've got life-saving medicine, self-driving cars. What else? What else is there?
Well, remember how this whole thing started with your coffee problem?
Uh-huh. Yes.
Yeah.
Yes, my never-ending quest for the perfect cup.
Well, imagine if your coffee machine could actually learn your preferences using this tech.
Okay.
Over time, it's experimenting, it's analyzing your feedback, and then eventually, boom, it just personalizes your coffee without you even having to think about it.
Okay, see, that I would invest in. That I would get behind.
Right.
But in all seriousness, this research is really eye-opening, I gotta say.
It really is. It really is.
It makes you realize how much potential there is.
And the most exciting thing is, we're really just getting started here. This paper gives us a glimpse into how we might approach all sorts of problems in the future.
Absolutely. So to wrap things up, we've really gone deep into the world of black box optimization.
I have.
Learned about this delicate dance between exploring and exploiting, and we've seen how this whole new generation of algorithms, like VHCT, is really, really changing things.
It's an exciting time.
It is. So next time you're facing a tough decision, whether it's something small or big life decision,
Right.
channel your inner VHCT.
There you go.
Weigh those options, think about the potential, and don't be afraid to explore a little.
Sometimes the best stuff is in those unexplored paths.
Couldn't have said it better myself.
There you go.
This has been awesome. Thank you so much for this deep dive.
This is fun. I enjoyed it.
Until next time, keep those minds curious and those questions coming.